So problem solving. So a few different types of problem solving that are on the MCAT. So the first one is trial and error. So that's like the basic type of problem solving. That's when you just try every possible solution until one works. But that's only effective if there are a few possible solutions. So if you have like a 4-number passcode and you remember the first 3 numbers, you can keep trying the different numbers for the last one. But that would only work if you have only a few possible answers to that problem. So that would only work a small percentage of the time. So next type is algorithms. So that's when you use like a specific formula or procedure that is known to solve a certain type of problem. So it would be like equations that we use in physics or chemistry, things that we know will give us the answer if we have the necessary information and the right equation. So that's like more like cookie cutter, like if you have specific things and a specific formula to use, you can use that. But most of the time you won't have that either. So we would have to use the next two, deductive or inductive reasoning. So deductive reasoning, also known as top-down reasoning, that's when you start from a general set of rules and you work your way down. So you take whatever you learned. So you take what you learned in the past, everything you know about this problem, and you work your way down. So you start from like a general set of rules and everything you know so far about it, and you use that to draw conclusions on the problem that you're given. And the opposite, so deductive reasoning, I think of it as like decrease. So you start from the bottom and you slowly go down. So you start from general and then you move your way down to the, keep narrowing it down until you reach your answer. So I think of it as like decrease. You start from the bottom and you start from the top and you work your way down. Inductive reasoning is the opposite. So that's when you start from the bottom and you work your way up. That's why it's also known as bottom-up reasoning. So that's when you take all the information that you were given and you work your way up to create a general set of rules or generalizations. So I think of inductive as like increasing. So you start from the bottom and you slowly use all the information you have to build up your answer. So those two are important. They're like opposites of each other. Deductive from top and down, and inductive bottom and up. Okay, any questions on this part? Okay. And another type of it's more like a easier way to answer questions. It's called heuristics. So that's when we use simplified principles to make our decisions. So it's like using like shortcuts and generalizations or like stereotypical answers to make our decision. So the availability heuristic, that's when we decide how likely an event is. We do it by how easily similar things can be imagined. So that's when we make a decision by thinking about like similar instances that we can imagine. So availability, I think of it as like when you think of all the available like similar available examples, and we use that to decide how likely an event is. So let's say so I like to think of it as like, say you work in like an ER, you'll obviously think that it's very likely that someone will have a heart attack just because of where you are. But if someone doesn't work in the ER, they wouldn't think that a heart attack is like a pretty common thing that people normally have. So heuristics are good, but it can create like false false circumstances and make you make bad decisions. So everything has to be taken with like a grain of salt, pretty much. So heuristics, they're good if for certain things, but it's also not wise to 100% trust them. So representative heuristics, that's when you sorry, I misspelled that. When you categorize items on a basis of whether they fit a prototypical or representative image of the category. So representativeness is when you think, when you're given like a certain concept or topic, and you automatically think of the prototypical or stereotypical representative of that category. So when I say, I don't know, when I, what's an example I can give? Yeah, so when I like, if I gave you like someone who's like, if I said like someone who's rich, maybe you think like they wear like a suit and tie or like fancy clothing, like designer clothing, even though that might not be the case. Rich people don't always like dress like that, but maybe that might be like the thing that you think of when I mention like a rich person. That would be like the representative heuristics. So sometimes it could be right, but don't trust it 100% of the time. So that classic example of when heuristics are not 100% reliable is the base rate fallacy. So that's when prototypical and stereotypical factors are used instead of numeric actual information. So that's when you ignore the information presented in front of you and use the stereotypical or prototypical image that you have of a specific topic. So going back to like the ER topic, it's like when if you ask an ER doctor what is the likelihood of someone having like a stroke, they would say maybe like 30%, because they have a lot of people coming in with strokes. But the actual number could be like 12%, but the ER doctor wouldn't believe that's 12% just because they work in a hospital and they see strokes all the time. So they're more likely to believe the own number that they made up, 30%, than the factual and actual number of like 12% that a study found. So it's easy to use heuristics to solve like a problem, but you always have to know that not everything can be like put into like a square. Not everything fits into the stereotype or prototype that you think of in your head. So just always keep an open mind.